Hello and welcome to this video that goes through a velocity time question for AQA Physics. So the question states that a graph below shows how the vertical component v of the velocity of a rocket varies with time t from its takeoff on level ground to the highest point of its trajectory. So to start off with, we consider a rocket, and the rocket might go up and down like this, but we're only interested in the vertical part and to its highest point. So we're only interested in here to here, and we're only really interested in the vertical component of that. So the first question states, take readings from the graph to calculate the average vertical acceleration of the rocket from t equals 0 to t equals 0.6 seconds. So to start off with, we need to consider what is the average vertical acceleration, and the average vertical acceleration is found, so average acceleration is equal to the change in velocity from start to end divided by change in time from start to end. So that's going to be v final minus v initial divided by t final minus t initial. There is a difference between the average acceleration and the acceleration at a particular time, because the acceleration at a particular time you would find by finding the tangent of or draw a line that's a tangent of the curve, and find the gradient of that tangent. So for this question, when we take readings, first of all we need to determine where is t equals 0.6. Now it's not super clear in this graph, but the major points here, there are 5 major points before it goes to 1, so it's split into 5 segments. So if 1 divided by 5 is 0.2, so each of the segments is equal to 0.2. We'll have a width of 0.2. So that tells us where t equals 0.6 would be, and then from there we are going to draw a line that takes us up to the graph. Now here that line's quite thick, so try and use a pencil or a thin line so you don't make any mistake. So here I'll draw the point so it's easier to see. So it meets the line at this point here. We'll zoom in. So it meets the point at this line here. So then we're going to go across to see where it crosses on the y-axis. So it crosses around about this point here. So this point here, to work this one out, we need to determine how many segments each one is. So we can see here that this is at 60, this is at 40. At the halfway point is going to be 50, so that's going to be this point here. And therefore, if we got 1, 2, 3, 4, there's 5 segments between 40 and 50, so therefore each one must be equivalent to 2. So this one is 52, this one here is going to be at 54. So therefore we can plug in our numbers, so we know that v final is equal to 54 and t final is equal to 0.6. From here it wants us to find from t equals 0, so all we're going to do is we're just going to draw a line that can meet that much the point, and we're going to find, in inverted commas, the gradient of that line. So it goes through, the initial point is at 0, 0, so t initial equals 0 and v initial equals 0. So we're just going to plug the numbers in. So the acceleration is equal to 54 minus 0 divided by 0.6 minus 0, which if you plug into the calculator you're going to get a value of 90 meters per second squared. Now you are given some leeway in this question, so you can have up to 93.4 meters per second squared, but I would try and get as accurate as you can, essentially. So it doesn't have to be perfectly accurate, but try and get the values as accurate as you can, because then it minimises your chance of losing a mark. But that gives you part A. If we go to part B states, use the graph to estimate the maximum height reached by the rocket. So to find the maximum height reached by the rocket, we're going to find the area under the graph. Remember, if you have a velocity time graph, then if whatever curve you have, the area underneath is equal to the distance travelled or the displacement travelled, depending on what you're finding. So in this situation we are looking for the maximum height, so essentially it doesn't really matter because it's above the curve. If it was below the curve, then you'd have to reconsider. You have to really think carefully what you're finding, distance and displacement, but when it's above the curve, distance would equal displacement. So then from here we need to find how, there are lots of ways of doing this, to find the displacement or distance that the rocket occurs. So if we move this off from our graph, so what we can do first is that one way is you can obviously count all the squares that are going to be, and you need to find the area of one of the squares. So we know that this is going to, so this is 0.2, and then if we do 0.2 divided by 5, each square is going to have a width of 0.04, and each one here, so each square here is equivalent to 2. So we know that the height of each square is 2. So from here you could find the area of a square is equal to 2 times 0.04, which is equal to 0.08. And that tells you what the area is of each square, so you might need that later on. To find the general area of this, like I said, there are multiple ways of doing it. This is the way that I would do it. So I can see that there's a big square in the middle. I already know some of the values, so this is going to be 0.6, this is 54, because I've already found that in part A, and then I draw a line across where it meets. So here we just got to be careful because the paper doesn't quite line up. Obviously it'll be slightly quicker in your one. So we draw the square there, and then we draw a line that goes down to meet the curve at a particular point, all the x's. So there we go. Okay, so here we've got a rectangle. We know that the height of that rectangle is 54, but we need to find the width. So this is going to be 1, this is 1.2, this is 1.4, this is 1.6, so this one here, if each one is 0.04, this one must be 1.56, so therefore we can find the length of that by doing 1.56 minus 0.6, which is equal to 0.96. So we know that this is 0.96 meters long, so therefore the area of this one is 54 times 0.96, which is equal to 51.84. So this area here, 51.84. And then from here you can, so here you are allowed some leeway in terms of drawing it, so it depends on how much time you have in the exam as to how long you want to spend on this to get a completely accurate value. So here we have a triangle. We can draw a triangle for this bit. So we're going to draw a triangle all the way down as far as we can go. So that's going to be our triangle from here. So it's got a height of 54. And it's got a length. So this one is going to touch at 0.16. So it's going to be 0.6 minus 0.16, which is equal to 0.44. And then you can plug that into your calculator. So 54 times 0.44 is equal to 23.96. 23.76, sorry. So that finds this area. Then if you wanted to collect all the ones here, so in this little section here that's not covered by the triangle, you have 1, 2, 3, 4, 5, 6, 7, and then here you could say these two make 8, these two make 9, and these two make 10. So there's 10 triangles in here, so that will give 10 times 0.08, so that gives you 0.8 meters. So that finds you all on this side. Then we've got the top. So the top, again, it does depend on how much time you have. Like the less time you have in the exam, the more you might have to cut your values down a little bit just to get an area. So for this bit here, again, we've got another rectangle. We can do two. Oh yeah, so we could do a triangle here to here. So that might just do a trapezium here. So we could do a length here, a length there, a length there, and we could do A plus B. So A plus B. Oops. So that's going to be A plus B. So this is 0.96 to go from here to here. So this is 1, starting from there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 times the length of one of our little squares, which is 0.04 at the bottom. So 9 times 0.04 is equal to 0.36. So it's going to be a plus b. So here it's going to be a plus b over 2 times h. So 0.96 plus 0.36 over 2 is equal to 0.66. And then we need to times that by the height. So the height here is going to be 1, 2, 3, 4, 5, 6, 7. So it's going to be 7, but each of the squares is 2. So each of these is equivalent to 2. So it's going to be times 14. So 0.66 times 14 is equal to 9.24. So again, we can fill in that area here, 9.24. And then finally, we go to the right hand side and we find the area here. So again, we go across. So we start from 1.56 and this takes us to 1.8. So this is equivalent to 0.24, and again this is a height of 54, so it's just going to be equal to, sorry I didn't put that in correctly, 0.24, so 0.24 times 54, which is equal to 12.96. So that's 12.96, and then finally, so this bit probably takes a long time. It'd be quicker to count the squares. So the ones that we definitely have, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12. These two look like 13. These two are 14. I'd say these two are 15. And then 16, and then last one gives feeding 17. So it's going to be 17 times, then we go back to the area of our squares, which was 0.08. So 17 times 0.08, which is equal to 1.36. Okay, then finally we add up all our areas together. So the total area here is going to be equal to 1.36 plus 12.96 plus 51.84 plus 9.24 plus 23.76 plus 0.8. And then we plug that into our calculator. So 1.36 plus 12.96 plus 51.84 plus 9.24 plus 23.76 plus 0.8 is equal to 99.96. And that would give us our total area underneath the curve. Yeah, so expect range. So you can get a wide variety of range. It depends on how much it is. It is an estimate though, so you might get something around the 90s, or you might get something around the 80s as well, depending on how accurate you have been. So that gives us our answer maximum height. So in our case, 99.96. But again, you are given a leeway. And then finally, assume that air resistance is negligible, calculate the time taken for the rocket to fall from its maximum height back to the ground. So here, if the rocket is to fall from maximum height, so essentially your rocket is at maximum height and then falls back down to Earth. So here, if it's reached the highest point, then the velocity at that point is equal to 0. So we can say u equals 0. So if we write SUVAT, so we want to find, we know that the height we found already, so in our case is 99.96. U is equal to 0. The final velocity we don't know. Acceleration, this case we're going to take down as positive, so therefore the acceleration is equal to g, or 9.81, and the time is what we want to find. So from here we're going to use an equation that doesn't have time, and the only CVAT equation that doesn't have time is we want to find time, so we don't want an equation with v. The only equation that doesn't have v is s equals ut plus half at squared. So this is 99.96 is equal to 0 from ut plus a half times 9.81 times t squared. And from here we rearrange, it's going to be 2 times 99.96 divided by 9.81 is equal to t squared. So if we plug that into the calculator and square root, so 2 times 99.96 divided by 9.81, then square root the answer, gives us an answer of 4.51. And again, you would get a slightly different answer. So if you've got a lower height, you'd have a lower time. Again, you're allowed a range of answers here to find out your value. And that is the end of this question. If you have any further questions, please let me know.